Hello. Okay. Welcome to a chapter summary. This is chapter 4.1. It's work done by constant force. So, this is a little bit of grade 11 review, but here we are anyways. Work is the energy that a force gives to an object when the force moves the object. It's a little weird. So basically, let's say in me pushing this, I've done work. If I push it and it doesn't move, then there's no work. That's the idea. The movement, because of my force, means that I did work. So, yes, right there, obviously. A force does work on an object to move it. That's the idea. So let's say if you were shoveling, you're pushing on your shovel and you're shoveling away the snow. You're moving the snow with your shovel. So you're applying force on the shovel, and that's pushing away the snow. Now, one thing to consider is that a force is only applied in the direction of the displacement. So, if you're pushing at an angle, you're pushing obviously on the ground, which is level, then you only consider this component, the x component. So only F components parallel to the displacement do work. The equation for, here's a little picture. Here's our applied force. There's our X component. Here's our angle. So that's what we're doing. So the equation for work is F delta D cos theta. And this is measured in joules, or kilograms times meters squared per second squared, which is a scalar quantity. There's no direction for work. Alrighty. Negative work is when an object moves in a direction opposite the applied force. So if you had a force of friction acting on your object, and the object moved in one direction while the force was being applied in another, that's a bad example, but that's the idea. That results in negative work. And negative work results in the loss of kinetic energy. So, in terms of negative work, if you're looking at a question and you want to know if it's going to be negative work, you can tell from your angle. If your angle is between 90 and 180 degrees, then you know it's going to be negative work. It can't be 90 degrees. 90 degrees is a special situation. But if it's between 90 and 180, then it'll be negative work. And in terms of explanation, so we know that it's cos theta. We know it's cos theta because that's the x component of a force, and typically when you apply work on an object, you're applying in the x direction. So we know it's Fa cos theta because it's the cos component of a force. If we look here, cos is positive in this quadrant and this quadrant. This is the 0 to 180 quadrant, and that's the one we're going to concern ourselves with. So between 0 and 90, cos is positive. After 90, cos is negative. So that's why there's negative work. Finally, there's the idea of zero work. And once again, zero work is done if you don't move. If there's no movement, then there's zero work. Or when the direction of an object's displacement is exactly 90 degrees to the applied force, the work done is zero. So if you apply force directly perpendicular to your displacement, then your theta is going to be 90 degrees. Here we have our applied force, here we have our displacement, our theta is 90 degrees. And if you were to plug cos theta into a calculator, you would get 0, which implies that zero work is done. It's a little strange, but that's just how the physics rules work, and it's best not to question physics. So, we know that if the force is 0, if there's no force, then there's no work. If there's no motion, if there's no movement, then there's no work. And if the degree is 90 degrees, then there's no work. You have to consider all the forces that act in the direction of your displacement. So if you have an applied force and a force of friction, you'd have to find the difference of those two. But you wouldn't have to concern yourself with the y components. because a force is parallel to the displacement. Alrighty, see ya.